All right, hi guys. We're going to talk a little bit about some really helpful tools. First, start with early primary and work our way down the table. What I'm going to say about these tools is that they're not grade level band specific. Obviously, there are reasons to use them in primary and upper, but I'll talk a bit about that over the course of just taking a look at what we've got on the table. So the very first thing that I'm going to say is that the 10 frame is your best friend. The double 10 frame allows for us to do some fluency work, and what you're seeing here is just a cut up Poppet component, and you can actually do some combinations with students. So what goes with 6 to make 10? It's 4. We know that they're obsessed with these, so it's just looking for how can I utilize something that kids love into a math tool. The red and yellow counters being two different colors allows for us to kind of pose this 8 plus 6 more makes what, and then very easily make a friendly 10. Oh, that's right. 8 and 6 is the same as 10 and 4. But when we're problem solving, we know students really need to be extremely concrete, right? So there are 4 dinosaurs eating under the trees. Well, I don't have a tree, but I have a cave. So I have 4 dinosaurs that are eating in the cave. So I can count it out. 1, 2, 3, 4, and act out this problem. Oh, guess what? Some more joined them. Now there are 11 altogether. So this idea of being able to have a concrete tool to practice that makes us act out the problem and get to that end goal. There are so many things out in the world that help us. You go to the dollar store, you can find a million great tools. Do you see how I could have a conversation about this is full, how many, versus this is not full, how many? And it helps us really understand what is 10. It's a critical skill for all learners, not just the primary kids. And so some of our kiddos, when they're doing one-to-one counting, this idea of counting one object at a time is really difficult. So I use an egg carton because you can actually place the items in there and really promote that one-to-one separation. When students are making the transition from counting by ones to counting by units, they're going to need some time before they start working with these base 10 blocks that are already in the rod. When I hold up a 10, it can't really be definitively 10 without counting it, right? Unless you know that by heart. But when you look at this train, this Unifix cube train or any kind of 10 frame, can you tell it's 10 without counting? Absolutely, there's 5 and 5. So it can be subitized, and students count that unit more confidently when they really believe that it's 10. So supporting that 10, 20, 21, 22, 23, 24 helps them recognize the unit versus by ones. So then we graduate to this concept of, wait, we're in the upper grades now. We have to connect this work to decimals and fractions and multiple groups. Well, when we are thinking about what's the purpose of counting money, right? We all use a card now. But this idea of being able to connect the coins, 10, 20, 21, 22, 23, 24. Do we see the connection? We have an abstract group of 10 versus an actual group of 10. And so this counting of money may need to be connected to its place value component. So we're not only learning maybe a not as essential skill, but we're connecting it to the very essential, which is the unit of 10. And wait a minute, this is a tenth. This is the decimal version of money, and we can talk about fractions in that relationship as well. So now I get to represent with base 10 blocks, but then this idea of a fractional amount. So if this is one whole, how much do I have here? Can I count by fractions? I can see that it's 3 wholes and 3/4. What might that look like with money? Could I make the connection between an area model and a concrete tool that represents a fraction and the decimal value? Do you see how much more accessible this would be within introducing a decimal value than just shading a grid on a page. And don't forget about that multiple groups. Guys, I know every single one of you is struggling to ensure all students are fluent with their multiplication facts. One of the very first things that we need to know is, can they skip count? And they're gonna have to have those objects in front of them when they're skip counting at first. And this idea of skip counting doesn't come naturally. You might have to do skip counting by twos first. Why? It was introduced in first grade and second grade. And skip counting by those multiple groups is something that's explored early and often. So maybe they start off saying 2, 4, 6, 8, 10, 12, and counting by twos. You might also do whisper counting with this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, before they do 4, 8, 12, 16, 20, 24. We need this skip counting routine and this idea of transitioning from counting by ones to counting by groups and equal groups. We need it concretely first. It's not going to come together with just rote counting. Thanks, guys.